Good morning, my dear children. Today we are starting a new lesson, that is unit number 4, transition and inner transition element. Transition and inner transition element, page number 100. Here, what is our today learning objectives? To learn about the position of D and F block elements in the periodic table. The position of D and F block element in the periodic table. Second one, the general trends in properties of element of 3D series. The general trends in properties of elements of 3D series. Here, what is about the transition element? Before that, we can discuss about the definition for transition element. The metallic element that have incompletely filled D or F subshell in the neutral or cationic state are called transition metals. The metallic elements that have incompletely filled D or F subshell in the neutral or cationic state are called transition metal. The transition metals are the element whose atom has an incomplete D subshell. We know that S subshell, D subshell, P subshell and F subshell. Am I right? Here the transition metals as an element whose atom has an incomplete D subshell, which can give rise to cations with an incomplete D subshell. Here the central position of the periodic table between the S and P block elements, they are occupied. The transition elements are occupied the central position of the periodic table. Please just to see the periodic table, page number 101. The transition metals, the periodic classification having there, the transition metals are occupy the central position. That's one of the color, pink color is mentioned like that. That are called transition metals in the periodic table. Left corner, left side, S block elements, and the right corner, right side, P block occupy. In between the S and P block elements, the transition elements are occupied. The properties are transitional between highly reactive metals of S block element and the element of P block element, which are mostly non-metal. The transitional metal means this is the first one, first group, second group. That is about the S block element. After the second group, third group, third to 12th group, third, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. The third group number 3 to group number 12 are called as transition metal. We know that there are 18 group of element. Am I right? 18 group of element. The first two groups are called as S block element. The first group, that is starting from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are all S block element. Am I right? And including beryllium, magnesium, calcium, strontium, barium, radium, etc. These are all S block element. After that, the third group starting from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are all transition element from starting from third group to 12th group. Here, except 11th group. 11th group means copper, silver, gold, rhodium. These are all except this 11th group. All the transition metals are hard, and all the transition metals have very high melting point. The transition metals, iron and copper, play a very important role in the development of human civilization. Iron means, all of you know about that. Iron, nowadays the ions are used in a building purpose. I'm right, building purpose. For concreting the walls, we are using iron. Very, very important. And about the copper, very, very important about the copper for the electrical wires, copper vessels, copper utensils. These are all made up of by copper. So these are all very important nowadays. And about that, other important transition metals, about the tungsten. Tungsten, very, very important. Tungsten for the light bulb filament. Titanium. Titanium, about the fourth group, titanium, fourth group metal. Titanium is very, very important for the manufacture of artificial joint. Titanium, fourth group metal. Molybdenum. Molybdenum is about the fifth group. Is used in a boiler plants. And about the 10th group about the platinum. Very, very important as a catalyst. Some of the reaction catalyst used as a platinum. And about the iron. Iron is about the 8th group. About the hemoglobin. We know that in hemoglobin. Cobalt is about the 9th group in vitamin B12. There are very applications. So anyhow, in this lesson, we are going to learn about that the general trends in properties of D block element. One of the general trends in the properties of D block element with a specific reference with the 3D series and their characteristics, chemical reactivities, some important compounds, example potassium permanganate, potassium dichromate. For example, from the page number, from this lesson, the page number 101 to 117. 101 to 117 pages we are discussing about the transition metals and about the F block elements. From the page number 118 to 124, we are discussing about the F block elements. So today our the learning objectives. What is about the learning objectives? To discuss about the position of D block elements in the periodic table. Position of the D block element. We know that the periodic classifications of the element, that is a transition metal, occupy from the group 3 to group number 12. Please all of you look the periodic classification. First group is, I told that that's the first group goes to the S block element. That S block element is mentioned as a blue color. Next, from the group number 3, scandium. Group number 4, titanium. Group number 5, vanadium. 6, chromium. 7, manganese. 8, iron. 9, cobalt. 10, nickel. 11, copper. 12, zinc. Like that. They are arranged from 3 to 12 in the modern periodic table. The transition metals are occupying. From the remaining about, already we discussed about the previous lessons, that is about the P block element. Already we discussed that one. From boron to inert gas, that's a noble gas. We discussed about the P block element. Anyhow, we are discussing about only the D block element. So the last having 2 rows having, that is about that F block element, that we can be discussed later. Okay. Anyhow, from the D block elements composed of 3D series, there is a 4th period. We know that the periodic table, we have the 7 periods, period number 1, 2, 3, 4, 5, 6, 7. The 4th period, that is a 3D series, scandium to zinc. Scandium, that is atomic number from 21, scandium atomic number 21, titanium 22, vanadium 23, chromium atomic number 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, zinc 30. But scandium to zinc, we have 10 elements. 4D series fixed period, that is yttrium to cadmium, that also having 10 elements. And the fifth series, sixth period, that is about we are saying the lanthanum, hafnium to mercury. Group number 12 elements, that is zinc, cadmium and mercury, do not have partially filled d orbital. They do not have partially filled d orbital, either in the elemental state or in the normal oxidation state, but they are treated as a transition element. And about that, what is the meaning here means, here the properties of this are then extension of the properties of the respective transition element. Why they are considered as means they are treated as a transition element because their properties, these element properties are an extension of the properties of the respective transition element. The seventh period element starting from actinium, rutherfordium to copernicium, that is Rf to Cn, also belongs to transition element. Here these are all, everything are the radioactive element except actinium. All the remaining elements are synthetically prepared. They have very low half-life period. So next we can be discuss about the electronic configuration. Already we discussed about the electronic configuration thoroughly in the p block elements. Here the electronic configuration of the element using by alpha principle. Here what is about the alpha principle? The electron filled atomic orbital of an lowest available energy level before occupying higher energy level. So first you have to occupy the lowest available energy levels before occupying higher energy level. About the Hund's rule, what is about the Hund's rule? These are already we discussed in the 11th grade. Hund's rules means about, we know that one, that no two electron can be identified by the same set in quantum number. That is about the Hund's rule. Alpha principle, the electron first filled in the 4s orbital. The electron first filled in where? The 4s orbital before 3d orbital. For example, if you are writing the zinc what is atomic number of zinc? Z10. Symbol is Z10. Atomic number is 30. So here, first fill the 4s orbital before 3d orbital. The filling of 3d orbital start from scandium. That is atomic number 21. Its electronic configuration is that is about, we are writing the electronic configuration of scandium is EC is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Here we are writing the short form. How will you write the short form here? Argon. We are using argon. Why we are using argon? Because atomic number of argon, atomic number is 18. So we are taking here argon like that. Remaining is 3d1 4s2. Why we are writing the 4s2 outside means because it is a completely filled. 4s is completely filled. So here D subshell having only one electron. Am I right? Because the atomic number is about the 21. Am I right? Here the electrons of the successive elements are progressively filled in 3d orbital. And filling the 3d orbital is complete to zinc. Zinc means the atomic number is 30. And this electronic configuration is, how will you write the electronic configuration of zinc? 30, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. How will you write the short form? That is argon, AR, argon, 3d10, 4s2. There have two exceptions in the mentioned progressive filling 3d orbital. Here, there is one of the important point. There is a chance of acquiring half-filled or fully filled 3D subshell. Suppose it is happened means you have to give the priority as their stable configuration. One of the very important. In the 3D orbital, if there is a chance of acquiring half-filled or fully filled 3D subshell, it is given a priority as their stable configuration. For example, one of the very good example here means chromium and copper. The symbol of chromium is Zr and copper is Zu. Chromium atomic number 24, copper is 29, Cu 29. How will you write the electronic configuration of chromium and copper? Actually, writing the electronic configuration of chromium, that's atomic number is 24, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. 3d4 like that we have to write. This is the actual form. But it is not a correct form. How to change? You have to give a, if there is a chance of acquiring half-filled. They have a chance. That's one of the very good chance here for acquiring half-filled. Suppose one of the electron from 4s to here for the 3d 4s1. We are changing like that and we are acquiring here means 3d5. We have a chance to become a half-filled. So we have to write the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Like that we have to arrange like that. In short form we are writing means argon 3d5, 4s1. Argon 3d5. Okay, there is a chance of acquiring half-filled. What about the copper? Actually, if you are writing the copper means copper. If you are writing as per the order means we get the answer is like that. Argon 3d9, 4s2. Like that it will become. Am I right? So it is not a correct. Here also we have a chance to fully fill the 3D subshell. How can we arrange means we have to arrange like that. Argon 3d10, 4s1. Argon 3d10, 4s1. So anyhow, the general electronic configuration of D block element, one of the very, very important point, the general electronic configuration of D block elements can be written as noble gas. You have to write like that. Noble gas N minus 1 D 1 to 10 NS 1 to 2. Here N is equal to 4 to 7. N is equal to 4 to 7. In period 6 and 7, except La and actinum, lanthanum and actinum, the configuration includes N minus 2. This is for F block elements. Okay, this is for F block element. N minus 2. F orbital. Noble gas N minus 2. F 14. N minus 1. D 1 to 10. NS 1 to 2. Okay. For here N minus 2 means don't forget that it is a F block configuration, that is F14, n minus 1, D 1 to 10, ns 1 to 2. Okay, this is the electronic configuration of D block and F block elements. Next, we can be discuss about that. General terms in properties. What are the general terms in properties? First, we have to discuss about that. Metallic behavior. Metallic behavior. Here, we know that electropositive metals, or electropositive element, that we are saying metallic behavior. A tendency of element to form a cation by losing an electron. Tendency of element to form a cation by losing an electron. That is about the metallic behavior. All the transition elements are metal. We know transition metals are good conductors of heat and electricity. The metal of group 1 and group 2, all the transition metal except group 11 are hard. We know already, we discussed about that group number 11, that is copper, silver, gold, rhodium. These are all what? These are all not a hard metals. Okay, others are hard metals. And one of the very important point, silver has the highest electrical conductivity at room temperature. Silver have the highest electrical conductivity. Okay, as room temperature. So one of the very important for the one-word question. Don't forget that. Okay. Next, we can be discuss about that. Most of the transition element are hexagonal close packed, cubic close packed, and about that body-centered cubic, which are characteristic as a true metals. True metals means we are saying about the hard metals or heavy metals. For example, cadmium, mercury, lead, arsenic, etc. These are all for true metals. Here, one of the tabular column is given like that. Tabular column. Okay, tabular column about that HCP, BCC, FCC, DHCP. These are all as one of the given tabular column. That is a page number 103, figure 4.2, lattice structure of 3D, 4D and 5D transition metals. We know that one. That is a hexagonal. HCP means a hexagonal. Already we discussed about in the solid state lesson. Am I right? Solid state lesson. Come to the page number. If you come to the page number 191, there we having about that CCP structure, HCP structure, everything we discussed about that. That's a A layer, B layer, A layer. And again, the CCP structure means we know that on A layer, B layer, C layer, again A, like that. Okay, that's a page number 191 about the HCP. Already we discussed about that. Okay, am I right? Next about that, BCC structure also we discussed about in the page number 183, page number. They are also having one of the body-centered cubic. Body-centered cubic. And about that face-centered, that also we discussed about the face-centered, page number 184. That also having some cubic units. Am I right? These are all here also transition element also are hexagonal close packed, cubic close packed. For example, scandium, one of the blue color, like that's not a blue color, like the green color. Some elements, that is scandium, titanium, ytterbium, zirconium, hafnium, etc. And also having cobalt, etc. Also having these are all HCP, hexagonal close packed. Am I right? Hexagonal close packed. Next about that, one of the blue colored, that means vanadium, chromium, manganese, iron, etc. These are all something mentioned like that, blue colored, about the body-centered cubic arrangement. Next one, red color like that, face-centered, nickel, copper, etc. Okay. Next one more, DHCP. DHCP means, I think that the third row having double hexagonal close packed. Next about RH also, that's a rhombohedral structure like that they are arranged. Okay, please look and learn. Okay, next about that, one of the important point, as we move from left to right in the periodic table, the transition metal series, the melting point first increases. Okay, what happened to the melting point? The melting point first increases as the number of unpaired electrons available for metallic bonding increases, reach a maximum value and then decreases. Okay, first the number of unpaired electron increases step by one by one, because scandium atomic number is 21, they have unpaired electron is 1. Am I right? Like that, increasing number of unpaired d electrons available for metallic bonding increases, reach a maximum value and then decreases as the d electron pair up. Now the pairing takes place after become less available for bonding. Please look the graph here. Scandium first melting point is increases to titanium, and next to vanadium, and next almost constant to chromium. Then again decreases, am I right? From manganese. Then again increases. Then again somewhat increases. Then the next also decreases. Here scandium, what's the reason means? Scandium melting point is scandium atomic number 21, 1814 Kelvin. Next, to vanadium. Vanadium, that is a 2183 Kelvin, vanadium. Next, chromium, almost close because that 2180 Kelvin for chromium. Okay, next, manganese, it will be decreases, am I right? Decreases. And again it will be increases to iron, cobalt, nickel, again decreases. The middle of the transition metal series, that is Mn, manganese 25, it indicates that it contains D5 configuration. D5 configuration means all of you know that one. D subshell. D subshell, how much electrons can be occupied? The maximum number of electrons is 10. Am I right? What are the D5 configuration? DXY, DXZ, DYZ, DX square minus Y square, DZ square. Here manganese. Here each one orbital electrons are singly filled, half filled, am I right? So the melting point is decreases. Next again electron adding to ion, cobalt, nickel, so slightly increases. Next to copper to decreases, zinc is completely filled, so again decreases. This is about the variation of melting point in 3D series element. Okay, my dear children, today I am giving the assignment. Try to learn about that, the metallic behavior of the transition element. Please learn that one. It's a very important area. Try to learn this one, metallic behavior. Thank you all of you. Thank you. Have a nice day.